You should see my screen now. I'm showing on the hierarchical approach. Okay, the second technique in clustering. We have discussed on the first part, which is on k-means. All right, so okay, let me on my pen. All right, so we have this. When we say clustering, it falls into two main categories or main techniques. One, what we call as partitional. Okay, partitional. The other one would be the hierarchical. So the partitional method example is like k-means, which we have discussed in the previous lecture. All right, this is the most basic form of clustering, right? So, but with the clustering, okay, we may face several problems. All right. Because the clustering is where we have to average all the points that we have. All right, so if we have the extreme values, that extreme values will dominate your calculation, right? And with that problems, okay, researcher introduce another technique called hierarchical approach. Okay, so this is the one that we will discuss today. So what is hierarchical clustering? All right, the names of hierarchicals shows that we basically want to come up with a hierarchical form of structure, right? We want to produce a set of nested clusters which will be organized in the form of hierarchical tree. Okay, so like this one, and this is the one that we call it as dendrogram. So the objective of this topic, all right, at the end of this topic, you should be able to, to understand the hierarchical concept, right, on how to, merge the points with several techniques, which we will discuss later on. And then you should be able to, construct this dendrogram, right, from the points that we have, clustered. Okay, so we may use, okay, in this case, we can use the distance metric, right? Of course, this is the most general forms of measuring the clustering, all right? So we will use distance metric as a clustering criteria in this context, all right? So if you're aware in the k-means method, we need to identify the number of clusters, right, prior to the clustering process. So with this hierarchical clustering, the method doesn't need the number of clusters or k as the input, right? But it need what we call as a termination condition. Okay, so that is the difference between the two. So there are two main categories that fall into this method, what we call as agglomerative. Another one is divisive. So the agglomerative, if you look at this, it runs from the left to the right like this, where divisive is the opposite of the agglomerative, from the right to the left. Okay, we start the agglomerative from every single point. Right, we move to the right to step 1 to step 2, where we will merge one clusters after clusters until at the end we have one single clusters. So that is agglomerative, right? Or simply known as aggness. The other method called divisive is where we have one main clusters and then we divide and further divide until we have all the basic form of points, right? So these two categories called aggness and diana. So as I mentioned to you just now, this is more on the explanation, okay, on the two types of hierarchical clustering, agglomerative and divisive. So this hierarchical clustering, okay, was introduced by this researcher quite long time ago in 1990, right, and was implemented in statistical packages known as S+, where they use the single link method. Okay, they use a single link method, the method called single link, and they use the dissimilarity matrix. So we have discussed on the dissimilarity matrix. So this matrix will be used throughout the clustering process. All right, so whether you apply the k-means, whether you apply the hierarchical techniques, right? So basically, right, we will merge the nodes that have the least dissimilarity. Okay, the least dissimilarity, or what we example is like we will use the mean Euclidean distance, and we will go on in a non-descending fashion, right? So and until at the end all the nodes, okay, belong to the same cluster. So we look at this final results. So we'll have two clusters, right? So this is the algorithm of the agglomerative, right? So the basic algorithms contains 6 steps, where at the first step we have to compute the dissimilarity matrix, and we will let each data point be a cluster. Then we will merge the two closest clusters. Once we've done this, we will update the dissimilarity matrix, and we will repeat this until we get a single clusters, right? So the key operation here is the computation of the dissimilarity of the two clusters. All right. So this is the overview of the dendrogram, right? Where it will shows how the points here, okay, be merged into one layer to another layer, right? So this is a point. So in the beginning, we will regard this as all the cluster point, right? The clusters. So with these 3, 5, and 9 means we have 9 clusters in the beginning. All right. So now I will use the word clusters. Okay. So in the beginning we have 9 clusters. All right. So we want to form one single cluster towards the end. Right. So we can decompose, right? We can decompose these data objects into several levels of nested partitioning. Okay, so means that, okay, I can cut my tree like this, right? If I cut my tree like this, okay, so this is the cluster that I will have. Okay, this is one cluster. This is another clusters, and this will be another clusters. So if my threshold or cutting point is here, so this is the cluster that I will form. So similarly, all right, if I have another threshold, okay, and any other points, you can look at the how many clusters that you can produce at every single threshold. So if let's say I cut my dendrogram at this point, okay, like this, okay, I want to cut it into here. So how many clusters do I have? So this is one cluster, this is another cluster, this is another cluster, another cluster, and another cluster. This is all the clusters. So I may have 1, 2, 3, 4, 5, 6 clusters if my threshold is here. Okay, so this is how basically we count the number of clusters by cutting the dendrogram at the desired level. Okay, so that we can produce numbers of clusters accordingly. Okay, so that is, how we can make use the dendrogram once we have built it. Okay, but throughout this lecture, I will show you how to create the dendrogram. All right, so this is just how to understand how we can partitions Okay, the different ways, I mean the nested partitioning. Okay. All right, so the idea behind these methods is when we want to, I mean, merge the clusters, okay, based on certain criteria that we have set, we would face some difficulty, right? So imagine that we have this starting situation, right? We have this starting situation. Okay, we will have, if you look at this, how many points do we have here? 2, 4, 6. Another 3 means we have 12 points altogether. Okay, so there are 12 points altogether. So we will start with clusters of individual points like this. Okay, that forms the basic clusters point. All right, and we will have, if we have 12 points, meaning we're going to have 12 by 12 of rows and columns to form the dissimilarity matrix like this, right? So this will continue up to P12. So this is the starting situation. So the intermediate situation will be where we will merge some of the points to form the clusters. So just imagine that this is the intermediate situation that we may face, right? So we may have these 5 clusters, right? C1, C2, C3, C4, and C5, whereby this could be the points that we merge, right, to form these 5 clusters. All right, so the idea is that we want to merge, right, because we want to form the clusters, so we have to merge. Okay, so we have to merge the 2 closest clusters, right? So imagine that we want to merge this C2 and C5, all right, and we want to, I mean, make use of this similarity matrix. So these are the areas that involve, right, of C2 and C5, isn't it? So now when we have this intermediate situation like this, the question is, how should we update this similarity matrix? How do we update this TM, right, when we have to merge between C2 and C5? So what will be the value of this thing, right? So with these issues, all right, researchers produce what we call as a technique to to merge, all right, to define the intercluster similarity from with one to another cluster that we want to merge, right? So there are several common techniques like the means approach or the mean technique, the mass technique, the group average, the distance between centroids, and so forth, right? So we want to see what is the similarity values, okay, between the points, right? So how to define, okay, one of the way is through the means approach or the mean techniques, where we will find, okay, the closest points between one point to another point in the other clusters. Okay, so we have one clusters like this. This is all the points, and this is the other point, the other clusters. So the mean is defined as the distance between these 2 points that can produce the mean distance, right? So that is mean. Of course, with the mean definition, I think you can also, I mean, understand the techniques of the maths, okay, where we will get the farthest distance between the 2 points from with one clusters and another clusters. Okay, then we will use this to update our dissimilarity matrix. Okay, so this is with the maths, with the farthest points between one clusters to another clusters. And then the next one will be like group average, where you have to measure every single points and then averaging it. So that's the name of group average. Another one will be the distance between centroids. So means you need to know what is the center point of each clusters. Then you get this as the measures to update your dissimilarity matrix. And The other methods, this depends on how you define it, right? So to conclude of this, all right, if we compare between the means and the max, right? The mean, also known as single link, all right, where the max is known as complete linkage. The single linkage or complete linkage, all right, denotes the other names of the mean and the max, right? So as I mentioned just now, the similarity of two clusters is based on the two most similar, the closest points. Okay, that's defined as single link in the different clusters. Whereas the max or the complete linkage is where it will measure between the farthest point from one cluster to another clusters. Okay, as shown here. Okay, right. So for the single link, the word mean means we use the mean operator, right? We use the mean operator to get the mean value. But for the max, you will use the max value. This is example, one of the intermediate examples. If we want to have these 4 points, we already merge these 2 points. So we will get all the distance between every single point of 3 with the 2, all right, and then 6 with the 2. Okay, that's why you have 3, 2, 6, 2, and then you have 3 to the 5, right, like this. You're going to have 6 with the 5, like this one. So you extract all the values here from the discriminating matrix and choose the one with the mean values. So this will be the 0, 1, 5. So this is the value that will be updated when we merge the 2 points, so the 2 clusters. Okay. So the opposite of the mean is the max. So just choose the max value. So that's basically how we, merge the points, okay, to form the clusters following the hierarchical approach, whether it's a mean technique, it's a max technique, the average, etc., and so forth. Okay, that's about it. Do you have any question to me? You can post in the chat area so that I can respond on the question be posted. All right, so I'll give you a few more minutes. If you have something to ask me, feel free to say something or ask something in the chat area. Okay. While waiting for that, I will open up the next topic, right, which is 6E. Yeah. Okay, let me check. Do you have any question from you guys? Okay, nothing. Right, so I will continue with the second part. All right, so the second part is where we will focus more, okay, on the specific ways on how to update the discriminating matrix as well as to create the datagram, right? So this is the objective. So we will look into the hierarchical approach by means of the mean techniques, right? So as I have explained just now, the mean, also known as single link approach, where we will form the clusters based on the 2 most similar or the closest points in the different clusters, right? Like this one. So this is the product of our process of the single linkage. Okay, let's have a look, okay, for better understanding, right? So this is the points that we have here. We have how many points here? We have 6, 1, 2, 3, 4, 5, 6, right? So this is the 6 points. And the points here is denoted by the x coordinate and y coordinate, right? Example like P1 here, the point number 1 is 0.4 of the x coordinate and 0.53 for the y coordinate. So this is P1, okay? Same goes the rest of the points P6. So what are the things that you notice here? This is all numeric attributes, isn't it? Right. So with the numeric attributes, then you can calculate making use of the Euclidean distance. All right. So this is the basic algorithm that we have discussed just now, and this is the formula to calculate the distance between the 2 points. All right. So having these points, right? So you have P1 to P6. The next step is to convert, right, or to calculate the points between the values between the 2 points of all the points that you have here. So we have P6, you have 6 points, mean you need to have 6 column P1 to P6, and you need to have 6 rows from P1 to P6 like this, right? So since this is the n times n table, so you don't have to fill up all the points. It is sufficient to fill up this area, the triangular approach of this side or the other side. So D will be the same values of the cells, right, of the discriminating matrix. So why 0? Because this is a distance between its own points. So all the values at the diagonal here will be 0. Okay, this is what you can see here. This is all 0. So the rest of the points need to be calculated accordingly. So here, right, for example, we want to look at the points of P1 and P2, whereas we have these two. Okay, also we want to work on, let me activate my marker of this one. So we have P1 here and P2, right? So this is the one that we want to calculate over here. So we have P1 and P2. So the x1 is 0.4, right? That is y 0.4 minus 0.22, right? So use the formula, apply to the formula. And then similarly, you have to get the difference between these two and put it here and calculate it. So based on these values, this is the final distance. Okay, this is the calculated values or the distance values between P1 and P2, which is 0.24. Okay, so continue doing to the rest of the pairs of P3 and P2, P4 and P3 and so P4 and P5 and so forth until you fill up all the points over here, right? So once you have done this, so this is what again we call as a discriminating matrix, and now you are ready to to create your dendrogram. So once you have the DM or discriminating matrix, the next step is to find the two shortest distance from the discriminating matrix to become the first two clusters. Right, so this is the DM that we have produced just now, right? So we have this, isn't it? So you have to trace what are the two minimal points, the two minimal point of the values that you have here. So as you can see here, which I also mark with the red color here. So you have the least value will be P3 and P6, this one. I think I use another colors. Okay, so because it's already red. Okay, let you go green will be better. Alright, so erase this one first. So the least value will be 0.11. The next shortest distance will be 0.14. So the first value of 0.11 belongs to P6 and P3. So when you want to draw the dendrogram, so this is the point P3 and P6. Right? So P3 and P6 with a distance of 0 and 1. So this is the distance value of 0. To be exact. So this will be 0.11. Right? So you draw like this to connect between the points of P3 and P6 of 0.11 as the height of the bar diagram over here. Okay, so now you already form one clusters of P3 and P6. The next one will be P5 and P2. So P5 and P2, or P2 with the P5 like this, with a height of 0.14. So this is 0.14. You can form another box that creates, okay, to link between the P2 and P5, right? So this is the first step. Okay, the first step is to find two shortest distances from the dissimilarity matrix to become your first two clusters, okay, as we have shown just now. So now moving on, go to the next one. When you go to the step 2, you need to form the next clusters by finding the point with the minimum distance, right, to the other points in the existing clusters. So now the task is that you need to update the matrix with the two newly formed clusters, right? So with this one, all right, so you already, need to combine P2 and P3, all right? A P3 and P6, okay? This one, and P2 and P5, P2 and P5, okay? So now P2 and P5, you can see here, P2 and P5, and this one is P3 and 6. Accordingly, this is P2, P5, this is P3 to 6. So now what will be the value for this one, this one, this one, this one, this one, isn't it? So you need to update the dissimilarity matrix. So at this point, okay, when you want to go to step 2, will be a bit critical, because you need to find out, okay, all the possible merging between the points that remains, right? So you have already merged between P3 and P6, okay? So this is P3 and P6, as you can see here, this is the first clusters, and the second clusters, as you can see here, P2, P5, so P2 and P5. So now you have the second clusters, right, which was donated in this dendrogram. Now the next task, or the next problem, the next process is to identify which points is the best point to be merged with the existing clusters. Would it be 1? Would it be 5? And so forth. So there are many possible ways to do this, right? So you may have, you may need to combine these 3 and 6 with 1, right? You may combine 3 and 6 with 2 and 5, right? You may combine 3 and 6 with the 4, right? You may combine 2 and 5 with the 4. You may combine 2 and 5 with the 1, and so on. So there are many possibility of merging, right? So with that, the easiest way will be to calculate all possible distances between the points as shown here, where what is the distance between 3, 6 to 2, 5? The distance between 3, 6 to 1, 3, 6 to 4. So you have 1, 2, and 3. The next one will be the distance to 5 to the 1, distance to 5 to the 4, as I shown over here just now, right? So we transform this into all possibilities into these tables, okay? So that will ease us to, to create the next level of dendrogram, right? So here, let me show just one example, all right? Okay, so we want to measure the distance between 3, 6, okay? This is one cluster, 3, 6, and 2, 5, all right? So what will be the value? So we will, based on this way, whereby you will split it into all possibilities like this, all right, where you have to know what is the distance of, how do I minimize this one? Okay, sorry about that. So you're gonna have 3 and 6 with the 2. Okay, this is not a good color to show. Okay, 3 and 6 with the 2. Okay, that's why distance 3 to the 2, right? Then you have distance 6 to the 2, 6 to the 2, and then 3 to the 5, 3 to the 5, okay, distance 3 to the 5, distance 6 to the 5, distance 6 to the 5, okay? So where do you get all this value? What is the distance 3 to 2? So go back to the original one. 3 to the 2 is 0.15. 3 with the 2 is 0.15. You bring it into this one, so it will be 0.15. Distance 6 to the 2, okay, 6 to the 2, 6 and 2, okay, all is 0.25, okay, so 0.25, and same goes to the next of the pairs of the sets. Okay, so you will get all these values and then choose the one with the mean. The names of the mean means you choose the one with the mean values, which is 0.15. So with these values, then you update your rows here of P36 with a P25, where you will get 0.115. How? It's like I show over here, right? So you have to repeat to the next possible merging, where this is 36 to the 1, this is to the 4, and so forth. And this is all the values that you have, and transform this, extract all this value to this new dissimilarity matrix table. Okay. So having this, this is the one that you have updated. So you have updated the dissimilarity matrix with all these values. And then what will be the next one? If you look at this, the next closest clusters are cluster 3 and 6, right? This is the minimal value, isn't it? And cluster 2.5 with the 0.15. So it means that when you want to form the merging, it will be 3, 6 with a 2, 5 or the height 0.15. Okay, so we will not combine 2 and a 5 with the 5. No. We will not combine 2 and 5 with the 1. No. All right. So based on our calculation, the most closest point will be to merge between the two clusters that we have just merged, which is 3, 6, 2, 5, this one, and the height will be 0.15. Okay, I think you are clear about that. And then the next will be to update your dissimilarity matrix table like this. Now you have these new points where you have P25 with 36, P25 to 36. Okay, and this value will be 0 because it's a diagonal value. It's just that you have to cut two measures. What will be the distance of these two to the 4 points to the P4? What is the values of the existing clusters to the 1? So apply accordingly like this, right? So you have to extract distance 36 to the 4, distance 25 to the 4, and you will get these two values, and the final will be 0.16, and then this one will be 0.22. So having these two values, okay, check your dendrogram table. Sorry, dendrogram 3, or dendrogram is a 3. All right, so the next will be to combine 3, 6 to 5 with the 4, P4. That's why you have this. So this is first step, second step, third step. The fourth step will be to combine this with 4. And the next one, definitely with the 1, right? Okay. What's the height? 0.22 based on our calculation here. So this is 0.22. So this is the updated matrix. And then the final one will be 0. So where we have used all the points, we have merged every single points to form the one single cluster, then we terminate. So that's how we form the dendrogram with the mean techniques, all right? So it has to be done step by step. You have to show every single step on how you merge the points from one level to another level. Once you have, created your dismantling matrix, you have to draw the dendrogram. So the dendrogram will be shown out one step after one step, right? So until we can get the final one. So the nested clusters will be like this, right? Where we have 3 seeds at the first step. Okay, this is the first cluster, second cluster, first cluster, second clusters. And the next one is with the third step. So this denotes the steps, the third step, the fourth step, the fifth steps. So this is our final dendrogram with the single linkage of the mean techniques. Okay, all right, so that's how basically the process of the mean or single linkage to create the dendrogram, right? Okay, we're done at that part. You are free to ask me, all right, on this thing. Okay, while I will open up the next slide, right, on the maths. So anything that been posted here? Okay, nothing. All right. Okay, if there's nothing, then I'll continue with the next one. All right. So this is based on the maths, right? So we have discussed on the mean, okay, on the mean approach. And now this the next one will be the maths, right? So I think that's not so difficult if you can understand the mean just now. So it's just the opposite ways of creating the dendrogram by means of the max value, right? So again, just to emphasize, the similarity of two classes now for the complete linkage is based on the two least similar or most distant points at the different clusters, where the calculation is using the maths, okay, but the selection to merge is still based on the minimum. So this is quite tricky for some students because you may miss the word mean here. Sometimes students will perform the maths and the maths. Okay, the key words here is that the calculation is use the maths, but the selection is still the minimum. So be careful on this thing, all right? Because the final will still be the same across any different techniques, but the way you calculate the similarity is based on the specific technique that we want to apply. Okay, in this case, we want to apply the maths, right? So similarly, we will have the dismantling matrix table like this, okay, where we have all the values that shows the distance between the points P2, P1, P3, and P3, and so forth, and we have explained just now, right? So now the issues now, okay, when we go to the next step. The first step, if you look at the first step, irrespective of the techniques, will be the same, where you have to find two shortest distance. The first step is the same for all the techniques, where you need to find the two shortest distance. When you want to merge, then you will be different a bit, all right? Will be different. So now we have 3 and 6. Okay, this is the two least values, 3 and 6, 2 and 5. Okay, this is the first step. Okay, the next will be how to update the matrix, right? So when you want to update the matrix, all these values, okay, what will be the values? Then we need to apply the max or complete linkage techniques. All right, so remember in the previous topic of mean, now this is mean, right? So the difference between the two is where we want to do the calculation here. So the calculation will apply the specific technique that you choose. This one is the max. So when you have all these values, okay, the distance between the points, the pairs of the points, like this, all right, you will have 0.15 as a result of the distances of the pairs like here. So the max of this will be 0.39. Okay. How about the next one? If you combine 3 6 with the 1, you will get 0.23. 3 6 with the 4, you will get 0.22, and so forth. Okay. So these are the values. Alright. So now the distance will be 3 6 to 5. 3 6 to 5 is 0.39. So this is the value for this one. Okay. And this is 0.23. 3 6 with the 1. 3 6 with the 1. Okay, this one. Right. And this one. So just fill up accordingly all the 5 points, 1, 2, 3, 6 points here. Right. So based on these values that you have, right? So the next step would be to choose the minimum, right? Remember, the calculation is based on the max, but the selection is based on the mean. So you calculate the distance, make use of the max values, but now when you want to select the points to form your dendrogram, then you have to find the one with the mean value. So that's the meaning of selection. You select the one with the minimum values, which is 0.22. The 0.22 is basically the merging between 3 6 with the 4, right? 3 6 with the 4. Oops. 3 6 with the 4, meaning for this one, this is the first step, remember? 3 6, second step to 5. The next step will be 3 6 here with the 4. Okay, so this will be the third one. Okay, can you differentiate between the earlier one with this one? The earlier one where we combine these two, but now here we will form the points from 3 6 to the 4 because this is the mean by means of the max calculation, right? So the newly formed cluster will be this one as shown over here. All right. So we will continue the next one. All right. So when we have all these things, the next one will be 3 6 with the 4, right? 3 6 with the 4. 3 6 here with the P4. So 3 6 with the 4. 3 6 with the 4. So this will be 0. So all here will be 0. And you need to find these three values. So as you can see here, this is how you calculate the distance. So the distance between 3 6, 4, okay, 3 6 to the 4, 2 to 5. This is how the values like. And then 3 6 4 to the 1. They will be how you calculate it, right? And the last one will be 2 5 to the 1 with this one. So just to show it to you again, in case you are not clear on how we calculate the distance. So as you can see here, this will be 3 6, okay, to the 4. 3 6, you have 3 6 here. This is 3 6, and then you want to know the distance 3 6 to 5 here, and another one will be the distance of 4, okay, 4 here to the 2.5. So this is one over here, this is another one. So 4 with this one. So this is the value. Where do we get this one? 3 6 to 5. Okay, 3 6 to 5. Look at the earlier one. 3 6. 3 6. Okay. 2 to 5. This is 039. So this is the 039. Okay. 4 and 2 5. Look at 4 with the 2 5. 4 with the 2 5. This is 0.29. So that's why you get 0.29 over here. So the max will be 0.39, right? And the next one will be 0.37. So another value will be 0.34. So you have three values here. Choose the one with the mean. Remember, select the minimum. So the mean will be 25 with the 1. So this is the first step. Okay, so this is the second step. Right? So this is the third step. and this will be the fourth step, isn't it? So the next one will be the final one. Of course, the final one will be all these points merged together like this, where this is the new dysmetric matrix, and then you calculate the distance accordingly, so you will get the final value of the heights of the distance, which is 0.39. So this is 0.39, and this will be the final updated matrix, and then we terminate. Okay, so this is how we calculate dendrogram. We draw the dendrogram by means of the maths calculation, but the selection will be the mean. So the final dendrogram will be like this. Okay, you have the nested clusters based on the step that we have shown just now. First step, second step, third step, fourth step, and the final one. Okay, and this is the dendrogram that will be produced based on the complete linkage. Alright, so the two comparison, you can see this is the first dendrogram produced by the single linkage method, and this is the one produced by the complete linkage method. Okay, that's all. So before I end up, the summary will be as mentioned here. So the word clustering or cluster analysis will group objects based on their similarity and dissimilarity, and has been applied widely in many applications, be it in medical, be it in the finance, be it in the business, be in the agriculture part, and so many other applications where it can be used, where we can benefit from these methods. All right. So we have, discussed on how to calculate the similarity as well as the dissimilarity. There's another term called proximity, all right? That refers to dissimilarity and similarity, all right? So the measures of dissimilarity will be different depending on the types of data that you have, whether you have nominal, binary, ordinal, numeric, and textual. But the one that I'll emphasize to you is on the numeric. So you need to know how to calculate the distance between the points, okay, by means of the techniques like Euclidean distance, okay, city block, Manhattans. Those are the commonly technique being used to calculate the distance, right, or similarities between the points. And we have discussed the two main techniques. One is the partitional based, the other one is what we call as hierarchical method based, all right, where we have discussed on the most popular technique called k-means, all right, and the hierarchical methods where we discuss the mean and the max technique, right, on how to form the dendrogram. All right, so the k-means is biased since it's considered the outliers, right? So it will have a very, we will have problems if we have a lot of outliers in the sample, okay? So, but however, it's the most simplest way of performing the clustering. All right, so then another one would be hierarchical methods. As we have discussed, you need to calculate the dysmetric matrix similar to the k-means approach, but here you have another knowledge where you can create dendrograms, okay, to represent the nested clusters that you have created by the process of hierarchical methods. All right, I think that's covered up the clustering topic for our course, right? So I hope you understand and you can further read through the textbooks, okay, any other references on the clustering to understand the whole concepts behind the techniques of clustering. Okay, with that, that's all on the presenting on my part, right? So I will wait for a few more minutes if you have questions to ask me regarding the clustering that we have discussed last week and this week and today, yeah. So I hope you understand all the basic concepts of clusterings. You know how to compute the disciplinarity between objects on different attribute types. You know how to to perform k-means clusterings. You know how to perform the hierarchical approach, creating the dendrogram by means of the map on the means tennis. Okay, if there's nothing, I think that's all from me. All right, thank you, class. See you again next time. Bye bye.